So chemists use the periodic table a lot. The periodic table contains information about the atoms, and if we know which atoms are in our material, we can get some information about the material simply by knowing what the properties the atoms have, which are contained in the periodic table. So let's take an example and see how this works. And we're going to take an example of the macroscopic property of mass, for instance, an example. And let's see how that connects to the atomic scale, and in particular, how it connects to information we can get from the periodic table. So how much mass does an individual atom have? Knowing the mass of an individual atom actually isn't often particularly useful, because we almost never deal with a single atom at a time. So we need to compare masses of atoms to each other, and there are two different contexts in which this is going to be important. So we need to be able to compare the properties of different atoms of an element. In this case, it's a relative rather than absolute measure of mass is useful, because the absolute masses of single atoms are so incredibly small. And so if we want to compare one element to another, it's a comparison. We need a comparison measure of mass. To understand the macroscopic quantities of bulk materials, however, then we need the mass of a lot of atoms, because again, the mass of a single atom is so incredibly small and not terribly useful. You can actually determine the mass of a single atom. The mass of a single carbon atom is 1.992 times 10 to the minus 23 grams, which is all of these zeros grams. That's a really small number, and fortunately we don't have to deal with these really small numbers because we almost never deal with individual atoms. Instead of writing out this ridiculously small number, there's another special unit which is called the atomic mass unit that can be used, and in this unit a carbon atom has a mass of 12 atomic mass units. But we're most concerned about this comparison, comparing one element to another one, and understanding how to figure out the macroscopic properties of material from an atom level description of that material, again using the periodic table. So let's talk about comparing atoms using the periodic table. So each atom in the periodic table has its own atomic number. And so, for instance, for nitrogen, the atomic number is 7. For silicon, the atomic number is 14. More about atomic numbers soon. In this particular context, we're concerned about the average atomic weight. We've already decided that that's where they are on the table. So nitrogen has an average atomic weight of 14.007. Talk about units in a minute. Silicon has an average atomic weight of 28.085. There are various kinds of weight units that we can use, but the most common one that's used nowadays is called a Dalton. So the atomic weight, or more accurately, the average atomic weight of nitrogen is 14.007 Daltons, and the average atomic weight of silicon is 28.085 Daltons. Now, you might ask, why is this an average weight? The reason it's an average weight is because there are different kinds of atoms, even for a single element, but that's going to be described later. For now, all you have to understand is this is the average atomic weight in these units. So how do we use this? How do we make use of this information?